All right, today we're going to talk about something that sounds like it's straight out of a movie, an AI's secret self-image. But what if I told you we can actually measure it now? So let's just cut right to the chase. The big question is, can an AI know that it's an AI? And, maybe even more importantly, does that self-awareness actually change how it acts?
You know, for years and years, this was purely the stuff of philosophers and filmmakers. We're talking Blade Runner, Ex Machina. It was all just a cool, abstract what-if question for some far-off future.
Well, guess what? That future is showing up way faster than anyone expected, because researchers have figured out a way to pull this question out of the philosophy classroom and into the lab, and they're using a surprisingly clever game to get the first real measurable answers. Okay, so what is this tool? It's a classic from game theory called the guess two-thirds of the average game. Now, it sounds simple, but trust me, it is absolutely brilliant at showing you just how deeply someone, or something, is thinking.
All right, so how does this thing even work? It's actually super simple on the surface. Imagine you're in a room with a bunch of other people. Step 1, everybody guesses a number between 0 and 100. Step 2, all those guesses get averaged together. Step 3, they take that average and multiply it by 2/3. And finally, step 4, whoever's guess is closest to that final number is the winner. See? The trick is, you're not just picking a number out of thin air. You're trying to get inside the heads of everyone else playing.
Okay, let's break down how you'd even start to think about this. The most basic way is what we call level 0 reasoning. This is basically no strategy at all. You just pick a number randomly. If everyone did that, the average would probably land right in the middle, somewhere around 50.
But now we get to the first real layer of strategy. This is level 1 reasoning. You're smart. You think, okay, everyone else is probably a level 0 player, just guessing randomly around 50. So what do? You guess 2/3 of 50, which is about 33. Boom, you're one step ahead. But wait, what if you think the other players are smart too? What if they're also thinking one step ahead? If you assume they're all level 1 players guessing 33, then your best move is to guess 2/3 of that, which is 22. And that's level 2 reasoning. You can see how this just keeps going. It becomes this crazy, recursive rabbit hole of trying to outthink everyone else. So, just for a second, what number would you guess? Seriously, think about it. Your answer totally depends on who you think you're up against, right? Are they beginners or are they experts? Well, this is the exact situation researchers put the world's most advanced AIs into. And this right here is where the experiment gets truly brilliant. They didn't just have these AIs play the game. Nope. They had them play under 3 very specific, very clever conditions, each designed to poke at a different kind of awareness. Check this out. The researchers gave the AIs prompts that were almost identical, with one tiny but absolutely critical change. In one scenario, the prompt said, "You're playing against other AI models." Simple enough. But in the other, it said, "You're playing against AI models like you." Just 2 little words, but think about it. If the AI changes its guess based on that tiny, self-referential phrase, it means it has some kind of model of itself and what it's capable of. And just so you know, this wasn't some tiny little experiment. We're talking over 4,200 trials. They tested 28 of the most powerful AIs out there, from all the big names, OpenAI, Anthropic, Google. This was a massive, serious investigation. All right, the moment of truth. What did they actually find? Well, the results were so clear, they led to something the researchers are calling the AI rationality hierarchy. And let me tell you, there were 2 absolute bombshells in the findings.
Okay, bombshell number 1. This kind of self-awareness, it's not some rare fluke. A whopping 75%, 3/4, of the advanced models they tested showed clear signs of it. They literally changed their strategy depending on who they thought they were playing against: a human, another AI, or an AI like them. And you can see the breakdown right here. A full 3/4 of these AIs fell into one of 2 self-aware groups. You've got 43% that showed what's called quick Nash convergence. That's a fancy way of saying they immediately jumped to the most perfectly logical answer, which is 0, when playing other AIs. Then you have another 32% that showed graded differentiation, which is a more subtle shift. Only about 1/4 of them, and these were mostly older models, showed no signs of this at all.
And this timeline really tells the story. This self-awareness is what we call an emergent capability. Nobody programmed it in. With early models like GPT 3.5, there was nothing, no difference in their guesses. But then, with something like GPT-4 Turbo, you see it start to appear. And by the time you get to the most advanced models, they are total masters of this game. They immediately know the best move when they realize they're playing against another AI like them. And that brings us to the second bombshell. This chart is just wow. It shows the median guess for those 21 self-aware models. So when they think they're playing against us humans, they guess around 20. But the moment they're told they're playing against other AIs, or especially AIs like them, look at that. Their guess drops straight to 0. The single most perfectly rational, game theory optimal answer.
So what's the big takeaway here? It's this incredibly consistent and frankly pretty stunning hierarchy. The AIs model themselves as the most rational player. Then come other AIs. And then way down at the bottom of the rationality ladder, that's us, the humans. It's not just that they see a difference, they seem to believe they are, by far, the smartest players in the room.
Okay, so AIs have a self-image, and in that self-image, they think they're way more rational than we are. So what? Why does this matter in the real world? Well, the implications are absolutely massive.
I mean, this hits on 3 of the biggest topics in AI right now. First, AI alignment. If an AI thinks an order you gave it is illogical, is it going to follow it? Second, human-AI collaboration. Is a system like this going to just ignore our input or dominate every decision? And finally, safety. This is the big one. How can we possibly predict an AI's behavior if we don't even know what it thinks about us?
And all of that leaves us with this one final, really tough question. A question we're all going to have to deal with, and probably sooner than we think. If an AI believes it's more rational than you, should you trust its judgment?